Hey everyone, this is part 5 of our Building with Claude API series. And in this video, we're going to talk about how we can get structured responses back from Claude. We know that by definition, LLMs are non-deterministic machines. That means when you give the same input to Claude, each time you might get a different response. Let's see that in action. Here we have a user prompt, generate numbers from 1 to 10. A simple prompt. Let's run it a couple of times and see the response that we get from Claude. So the first time we got this as our response. Now let's run this method once again with the exact same input. Okay, we're just going to run this now. Now it is just giving us the digits. It doesn't have the words next to the numbers. Okay, let's run this one more time for good measure. Now the header is different. So it is giving us these non-deterministic responses each time when we call the API. But there will be many scenarios where we would want something a bit more predictable, a bit more deterministic. Say you want to actually generate some, 4 or 5 numbers that you're going to be using as an input for, some other logic. Or maybe you want to generate some sort of a JSON config file that can be used with your application. In all those scenarios, you want to have something more predictable and structured. And that is where the concept of assistant prefilling and stop sequences comes handy. Okay, let's discuss these concepts one by one. Let's start with assistant prefilling. Here we are giving as input just a user prompt, which is basically this. So when we give this list as input to our API, all the context it has is that the user has said generate numbers from 1 to 10. And remember, Claude and all these LLMs are just predicting the next word, right? They're not exactly, thinking in their head, okay, I need to now generate numbers and, counting numbers from 1 to 10. They're just predicting. They're just like predicting the next word. So when in this sequence, when you say generate numbers from 1 to 10, the probable next word, the next token would be here. That's all it is doing. And then after that are the numbers from 1. So it's basically predicting each of the next words that are in that sequence. That's all it's doing. With that idea in our arsenal, we could do some interesting things. What we can do is we can pre-fill the assistant prompt a bit to nudge it in the direction where we want it to go. Along with giving this user prompt, let's also give an assistant prompt ourselves, right? So, it's again just an input, right? There's no rule that this assistant prompt should definitely only be generated by Claude, right? We can kind of pre-fill the assistant prompt a bit. So that's basically what we're going to do. So here when the user says generate numbers from 1 to 10, we are going to basically act as an assistant and just start generating the tokens in the direction where we want it to go. Okay, so we'll say here are your numbers in a single line, because we want it to be in a single line rather than in each line. That's it. We're not actually going to hard code the generation of the numbers. The actual heavy lifting we're not going to do, but we're just nudging it in the direction where we want it to go. And so now with this list where we have both the user prompt and also a pre-filled assistant prompt, if we give this as an input, what Claude is going to do is it's going to think that, okay, the user said generate numbers from 1 to 10, and the assistant has already started responding by saying here are your numbers in a single line. Okay, so it's just going to predict the next word that comes after this. So obviously here are the numbers in a single line. If it says that, it is going to generate numbers in a single line. Okay, so let's see if it actually does that. Okay, let's run these 2 cells and we can see that it did actually, generate the numbers in a single line, just as we had pre-filled here. It did do that here, but then it also went ahead and it says or in a list format from 1 to 10. It also, gives this option as well. Okay, there is a way to, not allow it to do this by means of using the stop sequence, which we'll be looking at in a couple of minutes. But at least we are able to nudge it in the direction where we want it to go. We are able to structure the response that comes back to us. It had given us the response in digits, but in this pre-filling, we can also nudge it in such a way that it gives us words for the numbers. Let's try that now. Here are your numbers in a single line in English words. Since we have pre-filled that to be in English words, let's see what happens now. And there you have it. Now, we are structuring the response. See? So here it says 1, 2, and 3 in words rather than in digits. But the thing is, it is also going ahead and generating the same in digits. We'll come to that in a bit. But this is pretty cool, right? Just by means of pre-filling the assistant message, right? We are able to nudge it. We are able to steer it in the direction where we want it to go. That is basically what this assistant pre-filling allows us to do. Now, let's talk about the second concept, which is stop sequences. Stop sequences essentially tell Claude where it needs to stop generating the response. The way you set it up is by means of using a parameter called stop sequences, okay? And it basically takes in a list of strings as its input. So let's give the input of maybe 5 to start with, okay? So if it encounters this particular sequence, FIVE, it will stop generating the response, okay? So let's run this now and see that it only generates up to 4, 1, 2, 3, and 4. And if you set this stop sequence to be maybe 10, you can see that it generates up to 9. So essentially what we are doing is kind of like string parsing, because Claude by its very nature is just predicting the next words, and by means of like pre-filling the tokens that it is supposed to generate, and also telling it that it needs to stop generating after these tokens, we are able to structure the response that we get and get a bit of predictability and determinism into this system, which by nature is non-deterministic. Now, to put this all together, let's generate a JSON config that we then load it into Python. Okay, so let's change the prompt here to be generate 3 colors with their respective hexadecimal values as JSON. Now let's feed this in without any assistant pre-filling. Okay, we only are giving a user prompt saying generate 3 colors with their hexadecimal values as JSON. That's the only prompt. Okay, and we'll even remove the stop sequences for now. Okay, so let's see what gets generated by giving this prompt as the input. So here you can see that it does generate the JSON for us. We have 3 colors and with their hexadecimal values also represented. The thing though is it adds this markdown formatting as a prefix and suffix. If we try to directly use this JSON in our Python code, we would be getting an error. So if I run this now, you can see that that response text is not something that we could directly use because of this prefix and suffix that is there when JSON gets generated for us. But now we have tools in our arsenal for removing this prefix. We can make use of assistant pre-filling, and to remove this suffix, we can make use of stop sequences. So as a first step, let's add our assistant pre-filling, set this role to be assistant, and we just pre-fill with this exact string. And when we give this as input to Claude, it will think that, okay, the assistant has already generated these characters. I just need to go ahead and start generating from here because this has already been generated by the assistant. We are essentially kind of manipulating Claude for our use case. Let's run this and see if that's what is going to happen. And yes, because we had added this initial pre-filling, the response that we get doesn't have this anymore. So that's pretty cool. But the suffix is still there. These backticks at the end is still there. And we know that we can make use of stop sequences to remove that. So we'll say stop sequences, and the stop sequence that we want to put in place is these three backticks. When it encounters these three backticks, it will stop generating the response. So let's run this now and we can see that we in fact have the JSON response as expected. And as a matter of fact, we can even load this into our Python code using the JSON module. So you can see here that we are able to get this as a Python object in our code. So this is how we can structure the responses that we get from Claude by means of using assistant prefilling and stop sequences. Follow along if you're exploring AI for your workflows.